Far out in the depths of space, beyond the swirling arms of our own Milky Way, lies a galaxy so bizarre it looks like it was plucked straight from a cosmic fairy tale. The Tadpole Galaxy, with its long, winding tail of stars stretching across the void, is one of the most peculiar sights ever captured by human telescopes. But its strange shape is just the beginning. Nestled within its glowing clouds of gas and dust are objects so mysterious, they've left astronomers scratching their heads for decades. We're talking about 30 anomalies ranging from inexplicably dense star clusters to regions of space that seem to defy the laws of physics, and the closer we look, the more questions they raise. Imagine a place where stars move in ways they shouldn't, where entire sections of the galaxy appear to flicker like a candle in the wind, and where some objects emit signals so strange they've been compared to the hum of a distant alien machine. This isn't science fiction, it's the reality of the Tadpole Galaxy, a cosmic oddball located roughly 420 million light-years from Earth. That means the light we see today left that galaxy around the time the first dinosaurs walked our planet. And yet, despite the unimaginable distance, scientists have managed to uncover secrets that challenge everything we thought we knew about how galaxies behave. What makes these 30 objects even more fascinating is that each one tells its own story, a story we're only just beginning to decipher. Some could be remnants of ancient collisions between galaxies, while others might hint at entirely new cosmic phenomena we've yet to name. And then there are those that resist explanation altogether, lurking in the shadows of our understanding, daring us to figure them out. That's the journey we're about to take, one that will stretch from the furthest edges of science to the very limits of human curiosity. By the time we're done, you'll never look at the night sky the same way again. The first of these strange objects lurking in the Tadpole Galaxy is something straight out of a cosmic nightmare. A vast, spiral-shaped nebula so twisted, it looks like space itself is being wrung out like a wet cloth. Astronomers call it the Twisted Nebula, and at first glance you might mistake it for a vortex swirling deep in the void. But this isn't just a beautiful cosmic whirlpool, it's a puzzle wrapped in enigma. The way its glowing tendrils spiral inward defies conventional models of nebula formation, as if some invisible hand is sculpting it from the shadows. What really sends chills down scientists' spines are the nebula's light patterns. Instead of emitting a steady glow, the gas clouds flicker unpredictably, brightening and dimming in jagged bursts, almost like a malfunctioning neon sign in the depths of space. Some theories suggest colossal magnetic fields, far stronger than anything observed in our own galaxy, could be warping the nebula from within. Others propose something even wilder, that the distortion might be the fingerprint of a hidden gravitational anomaly, perhaps a cluster of dark matter or even a rogue black hole drifting unseen through the chaos. The most unsettling part, this nebula shouldn't exist, at least not in its current form. Computer simulations struggle to recreate its bizarre structure without invoking forces we don't fully understand. It's as if the laws of physics behave differently here, bending to rules we haven't written yet. Every time telescopes point toward this eerie spectacle, they capture new details that deepen the mystery rather than solve it. And that's what makes the Twisted Nebula so captivating. It's not just an object in space. It's a question mark written in starlight, daring us to unravel its secrets. Just when you thought the Tadpole Galaxy couldn't get any stranger, along comes an object that seems to play tricks on the very laws of reality, the phantom star cluster. Picture this, a brilliant gathering of hundreds of stars shining brightly one moment, then fading into nothingness the next, only to reappear years later as if nothing happened. This isn't some glitch in telescope data or a trick of the light. It's a real, documented phenomenon that's left astronomers utterly stumped. At first, scientists assumed the cluster's disappearance might be caused by thick clouds of cosmic dust drifting between us and the stars, temporarily blocking their light. But there's a problem. When the stars vanish, the dust doesn't show up on infrared scans, which should detect even the faintest obscuring material. That means something else must be at work, something far more unusual. One leading theory points to gravitational lensing, where the warping of space-time by an invisible massive object like a black hole or dark matter clump could bend the starlight around it, making the cluster flicker in and out of view like a cosmic mirage. Yet even that explanation doesn't quite fit. Gravitational lensing typically distorts or magnifies light, not erase it entirely. Some researchers have floated an even wilder idea that the cluster itself might be caught in a rare, unstable orbit around a supermassive object, causing its light to stretch and compress in ways we've never seen before. Others whisper about more exotic possibilities, like quantum fluctuations in space itself or even unknown physics at play. What makes the phantom star cluster so unsettling is its unpredictability. Unlike other variable cosmic objects that follow regular cycles, this one fades and brightens at random as if it's taunting us. Every time astronomers think they've pinned down a pattern, the cluster defies expectations again. It's a cosmic ghost here one moment, gone the next, and cracking its code could rewrite how we understand the behavior of stars under extreme conditions. Until then, it remains one of the Tadpole Galaxy's most mesmerizing mysteries, a celestial enigma that refuses to be solved. Deep within the heart of the Tadpole Galaxy, lurking like a monstrous predator, is a black hole unlike any other. One that lashes out into the void with a furious jet of superheated particles stretching over 100,000 light-years. This isn't just a jet, it's a cosmic whip crackling with energy, and it's thrashing through space with enough force to reshape entire star systems around it. Scientists call this beast the lashing singularity, and its very existence throws a wrench into everything we thought we knew about how black holes behave. Black holes are supposed to be invisible, their gravitational pull so strong that not even light can escape. But this one betrays its presence with a brutal display of power, its jet twisting and curving as if some unseen force is bending it mid-flight. Normally, such jets shoot straight out from a black hole's poles constrained by magnetic fields. But the lashing singularity's jet writhes unpredictably, flicking back and forth like the tail of an enraged scorpion. Some sections even appear to snap, sending shockwaves of radiation rippling through nearby gas clouds. Theories abound as to why this happens. One leading explanation suggests the black hole could be spinning at near light speed, warping space-time around it so violently that the jet gets whipped into chaotic motion. Another idea points to an unseen companion, a second black hole locked in a gravitational dance, its tidal forces tugging the jet off course like an invisible puppeteer. But the most unsettling possibility, that something inside the black hole itself, whether its internal structure or an unknown interaction with dark matter, is fundamentally altering how energy escapes. Even more baffling is the jet's composition. Instead of the usual mix of electrons and protons, this one emits strange, high-energy particles that don't match any known astrophysical models. Some researchers speculate they could be fragments of primordial matter, leftovers from the early universe that got caught in the black hole's grip. Others wonder if we're witnessing an entirely new form of physics, where the extreme conditions near the singularity rewrite the rules of energy emission. What's certain is that the lashing singularity doesn't play by the rules. Its wild, unpredictable jets challenge the clean equations astronomers rely on to describe black holes, proving that even the most well-studied objects in the cosmos can still shock us. And until we unravel why it behaves this way, it remains a dazzling reminder some forces in the universe refuse to be tamed by human understanding. Tucked away in the swirling chaos of the Tadpole Galaxy, an impossible shape glows against the darkness, a vast, perfect hexagon radiating an eerie blue light. This isn't some trick of perspective or camera artifact. The glowing hexagon is a real structure, its 6 razor-straight sides spanning nearly 2,000 light-years, as if drawn by some cosmic architect. And the strangest part, there's no known natural force that should create geometry this precise on such a mind-boggling scale. At first glance, you might think of Saturn's famous North Pole hexagon, a 6-sided storm swirling in the gas giant's atmosphere. But that planetary oddity pales in comparison. Saturn's hexagon is a turbulent weather pattern, its edges blurred by winds. The Tadpole's version is unnervingly sharp, its angles precise down to the smallest measurable detail. Even more baffling is the energy pulsing through it. Scans reveal an unknown form of radiation emitting from its edges, flickering in rhythmic patterns that resemble, for lack of a better word, a heartbeat. Scientists are torn between 2 equally extraordinary explanations. The first camp argues for some freakish natural phenomenon, perhaps a standing wave in the galaxy's magnetic field or a shock wave frozen in time from an ancient collision. But simulations struggle to recreate such clean geometry without introducing exotic variables, like hypothetical quantum fluids or dark matter interactions. The other camp whispers a far more provocative idea. Could this be evidence of something artificial, not necessarily alien, though that tantalizing possibility lingers, but perhaps a megastructure forged by a long-vanished civilization now humming with dormant energy? One clue fuels the mystery. The hexagon's glow isn't constant. It pulses in bursts separated by exactly 47 hours when observed from Earth, a pattern so regular it defies random cosmic processes. Even stranger, the light's spectral signature doesn't match any known element or plasma state. It's as if the structure is running on physics we haven't discovered yet. What truly sets the glowing hexagon apart is its defiance of cosmic erosion. In a universe where gravity and time twist everything into chaos, this geometric marvel has persisted for millions of years untouched. Whether a celestial coincidence or something far more profound, it stands as a silent challenge to our understanding of the cosmos, a glowing question mark written in the fabric of space itself. Floating untethered through the Tadpole Galaxy's outer reaches, a lone planet drifts like a lost silver coin, one so unnervingly reflective, it gleams like a polished mirror under the light of distant stars. This isn't just another rogue world, it's an anomaly defying every expectation. The mirror planet, as astronomers call it, reflects nearly 98% of the light that hits it, a shine so intense it outshines most stars in its vicinity. For comparison, Venus, the brightest natural object in our own night sky, reflects only about 75%. This thing is something else entirely, a cosmic disco ball hanging in the void. What could possibly give a planet such a flawless metallic sheen? At first, scientists suspected an ultra-dense layer of frozen gases like methane or nitrogen might be coating its surface. But ice that reflective would require temperatures far colder than anything observed in the region, a paradox that sent researchers scrambling for answers. Then came the real shock. Spectroscopic analysis revealed no traces of ice or even natural minerals. Instead, the planet's surface seems unnaturally smooth, as if machined to perfection, scattering light with near-perfect symmetry. Some have dared to suggest it could be encased in a shell of pure metal, not just any metal, but one with properties we've yet to catalogue, the most tantalizing and controversial theory. The mirror planet might not be a planet at all, but a fragment of something far grander. Imagine a megastructure, perhaps a Dyson sphere or some other colossal artificial construct, shattered eons ago by a cataclysmic event. This object could be a surviving piece, its surface engineered to withstand the ravages of space. Proponents of this idea point to the planet's bizarre orbit, which doesn't align with natural formation models. Instead, it drifts as if launched, tumbling along a path that suggests it was once part of a larger system. But here's where the mystery deepens. The planet doesn't just reflect light, it modifies it. Certain wavelengths bounce back with strange distortions, as if passing through some kind of filter or embedded technology. One team even detected rhythmic pulses embedded in the reflected light, patterns repeating every 72 hours with mechanical precision. Are these echoes of some long-dead power source still ticking away inside? Or could they be artifacts of a natural phenomenon we've yet to comprehend? The Mirror Planet doesn't just challenge our understanding of planetary science, it holds up a mirror to the limits of our imagination. Whether a celestial oddity or a relic of something unimaginably advanced, it forces us to confront a humbling possibility. The universe might be far stranger, far more inventive than we've ever dared to dream. And until we can study it up close, its secrets will remain just out of reach, gleaming silently in the dark. Among the many cosmic oddities in the Tadpole Galaxy, few are as hypnotic as the Twin Pulsars, two dead stars spinning in perfect sync, their rhythmic pulses cutting through the darkness like a metronome set by the universe itself. These dense stellar corpses, each no larger than a city yet heavier than our sun, orbit one another so closely that a single trip around their shared center takes less than 2 hours. And here's what defies logic. Despite the chaos of their violent births and the mind-bending forces at play, their radio bursts arrive at Earth in flawless harmony, ticking with a precision that rivals our most advanced atomic clocks. Pulsars typically act like cosmic lighthouses, their beams sweeping across space as they spin. But the twins break the mold. Their pulses don't just align occasionally, they lock into sync as if connected by invisible threads. Each time one pulsar emits a burst, its partner answers milliseconds later with an identical signal, a phenomenon so statistically improbable it's like finding two grand pianos in separate rooms playing the same symphony note for note without a conductor. The reigning theory, their magnetic fields trillions of times stronger than Earth's, have entangled over time, creating a feedback loop where one pulsar's energy triggers the other in an endless cosmic call and response. This dance isn't just a spectacle, it's a goldmine for physicists. The twin synchronization is so exact that scientists have proposed using them as a natural timekeeping system, a celestial GPS to help navigate the galaxy. Unlike human-made clocks which drift over centuries, these pulsars have kept perfect time for millennia, their rhythm unshaken by the turbulence of space. Even more tantalizing is what they reveal about gravity. Einstein predicted that close-orbiting massive objects would warp spacetime, creating ripples called gravitational waves. The twins' orbits, decaying by millimeters each year, matches equations with eerie accuracy, offering some of the cleanest evidence yet for this phenomenon. Yet mysteries linger. Why don't their pulses ever stray, even as they whip around each other at a fraction of light speed? Some models suggest their crust's crystalline surfaces, harder than diamond, might vibrate in unison, acting like tuning forks resonating across the void. Others speculate that an unseen force, perhaps a shared halo of dark matter, keeps them tethered in this ghostly duet. Whatever the answer, the twin pulsars stand as a testament to the universe's ability to forge order from chaos, a rhythmic heartbeat echoing through the cosmos, one that might just hold the key to unlocking deeper truths about space, time, and the invisible forces binding them together. Hidden in the tangled streams of stars that make up the Tadpole Galaxy's tail, there's a patch of darkness so absolute it doesn't just blend into the void, it consumes it. The void cube isn't a black hole, a nebula, or any known celestial object. It's a perfect geometric abyss, a cube-shaped region roughly the size of our solar system where nothing, no light, no heat, no detectable matter escapes. Point a telescope at it, and the view simply stops, as if someone sliced a chunk out of reality itself. At first, astronomers assumed it was a glitch in the data. But after months of observation, the cube's borders remained unnervingly sharp, its edges precise at 90-degree angles, a shape nature almost never produces on this scale. Even stranger, the darkness isn't just an absence of light. Sensors aimed at the cube don't pick up cosmic background radiation, the faint afterglow of the Big Bang that permeates every corner of the universe. It's as if this region has been erased from existence, or worse, was never part of it to begin with. Theories attempting to explain the cube range from the mind bending to the downright terrifying. One leading hypothesis suggests it could be a cluster of primordial black holes, tiny, ancient remnants of the early universe, packed so tightly together they form an impenetrable barrier. These hypothetical objects, if they exist, would be smaller than an atom yet denser than a neutron star. But here's the catch: even a swarm of primordial holes should emit some gravitational lensing, distorting the light around them. The cube shows none of that, it's just empty. Then there's the more radical idea. The cube might be a dimensional rift, a tear in the fabric of space-time where our universe brushes against another. Think of it like a crack between two panes of glass. One side is everything we know, the other an unreachable realm with different physical laws. Some mathematical models support this, showing how certain high-energy events in the early cosmos could have stretched space so thin it split. But if that's true, what happens to matter or light that drifts too close? Does it vanish forever, or is it somehow translated into the other side? Perhaps the most unsettling clue lies in what the cube doesn't do. Most cosmic voids still contain traces of hydrogen or the faint whispers of particles. This one is utterly sterile, not even dark matter. The invisible glue holding galaxies together registers within its boundaries. It's as though the cube actively repels the universe, maintaining its perfect emptiness against all odds. Could this be evidence of an unknown force, a cosmic anti-structure governed by rules we haven't discovered? Or is it something else entirely, an artifact, a relic, or even a warning? The void cube refuses to fit into any box we try to put it in literally. It stands as a silent rebuke to our understanding, a geometric enigma floating in the chaos of the Tadpole Galaxy, reminding us that for every question we answer, the universe has a million more waiting in the dark. Amid the chaos of the Tadpole Galaxy's star-studded tale, an icy wanderer drifts silently until it sings. The singing comet isn't your typical frozen relic from the solar system's infancy. This colossal chunk of ice and rock, spanning nearly 50 miles wide, emits radio waves so melodious they've been translated into soundscapes resembling an eerie celestial choir. Unlike the random static of most cosmic bodies, its emissions form distinct harmonic patterns, rising and falling in pitch like a symphony composed by the universe itself. What could possibly make a comet hum? The secret lies in its dance with the solar wind, a relentless stream of charged particles blasting from nearby stars. As these particles collide with the comet's icy surface, they energize molecules in its coma, the hazy envelope surrounding its core. But here's the twist: instead of scattering chaotically, these excited molecules vibrate in unison, as if the entire comet were a tuning fork struck by an invisible hand. The resulting oscillations generate radio waves at frequencies that, when sped up for human ears, reveal hauntingly musical tones. Some recordings even mimic the structure of Earth's classical compositions, with repeating motifs and crescendos that feel almost intentional. Yet the mystery deepens when you examine the comet's path. It doesn't just interact with any solar wind. It seems drawn to regions where magnetic fields resonate at specific frequencies, amplifying its song like a cosmic amplifier. Imagine dragging a bow across a violin string, except the bow is a magnetic field line and the string is the comet's plasma tail. This resonance might explain why the harmonies remain stable over centuries, even as the comet barrels through turbulent space. The real mind-bender, the singing comet's melody isn't static. Over decades of observation, its music has evolved, shifting keys in ways that mirror mathematical sequences found in nature, like the Fibonacci spiral or prime number distributions. Some researchers suggest the comet could be acting as a natural converter, translating the raw chaos of space into ordered vibrations, a process that, if decoded, might reveal hidden patterns in the fabric of the cosmos itself. Others wonder if we're hearing the faint echo of a far older phenomenon, vibrations left over from the galaxy's birth, preserved in the comet's icy body like a fossilized song. Whether a cosmic accident or a fleeting glimpse of deeper universal harmonies, the singing comet challenges our perception of randomness in space. It's a reminder that even in the void there's rhythm, if only we learn how to listen. And as it continues its lonely journey through the Tadpole Galaxy, its song lingers, a ghostly refrain whispering secrets we're only beginning to understand. Buried in the Tadpole Galaxy's spiral arm lies a cosmic still life, a supernova frozen in time, its fiery tendrils suspended mid-explosion like a painting of chaos trapped behind glass. This is the fossilized supernova, a stellar corpse caught in a moment that should have lasted mere weeks but has persisted for millennia. Unlike typical supernova remnants, which expand outward in delicate filaments, this one appears locked in place, its shockwaves halted as if someone hit pause on the universe's most violent spectacle. At first glance, it looks like an illusion, a trick of perspective where the explosion's leading edge happens to align perfectly with our line of sight. But the data tells a different story. Spectrographic analysis reveals no Doppler shift, the telltale stretch or compression of light waves that would indicate motion. Those iconic tendrils of gas aren't moving toward us or away. They're stopped, frozen in a state that defies the fundamental laws of thermodynamics. Energy can neither be created nor destroyed, yet here, it's as though the supernova's fury has been siphoned away, leaving only a ghostly snapshot of its rage. Theories to explain this anomaly split into two camps. The first argues for an extreme environmental fluke. Perhaps the dying star's shockwave collided with an invisible wall of dark matter, a dense knot of the universe's most mysterious substance acting like a cosmic speed bump. Simulations show that under specific conditions, dark matter's gravitational pull could stall a supernova's expansion, though never with the precision observed here. The second camp proposes something far more unsettling, that the supernova didn't stop, it exited. Some versions of string theory allow for the possibility that high-energy events could briefly puncture spacetime, ejecting their energy into higher dimensions. If true, what we're seeing might be the afterimage of an explosion that literally left our universe behind. Then there's the matter of the remnant's core. Every known supernova leaves behind either a neutron star or a black hole, but scans of the fossilized supernova revealed nothing. No pulsar, no singularity, just an eerie quiet where a stellar heartbeat should be. The absence is so complete, researchers have begun probing whether the core could be cloaked by an exotic state of matter, like a quark star or a theoretical electroweak star, where physics bends under pressures so extreme the very nature of particles changes. What makes this object so unnerving isn't just its defiance of known physics, it's the implication that somewhere, somehow, the rules we take for granted can be suspended. Whether a celestial oddity or a signpost to undiscovered realms of science, the fossilized supernova stands as a monument to the universe's capacity for wonder, a reminder that even the brightest explosions can leave behind shadows we're only beginning to understand. In the swirling depths of the Tadpole Galaxy, two dwarf galaxies pirouette around each other in a celestial ballet so precise, it defies all cosmic convention. Known collectively as the dancing galaxies, these stellar siblings don't just orbit, they weave, dip, and spiral in syncopated rhythms that resemble a choreographed performance more than a gravitational dance. Most satellite galaxies follow predictable, elliptical paths dictated by gravity, but these two, their movements are erratic, almost playful, as if guided by an unseen hand. What makes their behavior so baffling is the sheer improbability of their coordination. Each galaxy tugs at the other with just enough force to create a complex, looping pattern. yet without the chaotic collisions or tidal disruptions you'd expect from such close proximity. Computer simulations struggle to recreate their motion unless scientists introduce an invisible factor, a massive halo of dark matter. This mysterious substance, which makes up roughly 85% of the universe's mass but emits no light, could be acting like an intricate marionette strings orchestrating their every step. But here's the catch: the amount of dark matter required would be staggering, far denser than anything detected in similar systems. Some astronomers propose an even wilder explanation. What if the dancing galaxies aren't just reacting to dark matter's pull, but to something else entirely? Imagine an ancient, hyper-advanced civilization, one capable of rearranging galaxies like pieces on a chessboard. While this idea veers into the realm of speculation, it raises a provocative question. Could certain cosmic anomalies be signatures of technologies operating on scales we can't yet comprehend? The galaxy's paths bear eerie similarities to theoretical models of stellar engines, hypothetical megastructures designed to harness galactic energy. Yet the most compelling evidence comes from their surroundings. The space between the galaxies crackles with unexplained radio bursts, as if their dance is generating waves of energy. These emissions don't match any known astrophysical processes, leaving researchers to wonder if they're witnessing a natural phenomenon or the faint echo of something intentional. Whether sculpted by dark matter, manipulated by forces beyond our understanding, or simply a freak of cosmic geometry, the dancing galaxies challenge us to rethink the boundaries of possibility. Their waltz through the void is a silent reminder. The universe loves a mystery, and some questions refuse to be answered with the science we've got. Drifting through the Tadpole Galaxy like a lost jewel, the crystal asteroid glitters with a brilliance that puts even the most dazzling cosmic objects to shame. Unlike the rough, cratered surfaces of typical asteroids, this one shimmers with near-perfect geometric facets, as if it were carved from a single, impossibly massive crystal. Spectral analysis reveals its composition isn't just crystalline, it's pure, lacking the usual mix of metals and silicates found in most space rocks. Instead, it's made almost entirely of a single mineral formation, its atomic structure so orderly it acts like a natural laser, amplifying and reflecting light with uncanny precision. The asteroid's origins are a puzzle wrapped in mystery. One prevailing theory suggests it's a fragment of something far grander, a hypothetical crystalline planet shattered eons ago by a cataclysmic collision. Imagine a world where the very crust was forged from gemstones, where tectonic forces over billions of years compressed carbon or silica into vast, continent-sized crystals. If such a world existed, the remnants of its destruction could still be scattered across the galaxy, and this asteroid might be one of its last surviving shards. But there's a catch. Crystals this large and flawless shouldn't form naturally, at least not under the conditions we understand. On Earth, the largest crystals, like those in Mexico's Cave of Crystals, grow slowly in mineral-rich water over millennia. In space, without liquid or stabilizing pressure, the process becomes even more improbable. Some researchers speculate the asteroid might have crystallized under extreme conditions near a neutron star or within the heart of a dying gas giant, where heat and pressure defied all expectations. Others propose something even wilder, that the crystal's growth was guided by an unknown force, perhaps a magnetic field so intense it aligned atoms into perfect lattices across light years. The most tantalizing clue lies in the asteroid's light. When struck by cosmic rays, it doesn't just scatter photons, it sorts them, emitting beams of specific wavelengths with unnatural consistency. It's as though the crystal functions like a cosmic prism, filtering and refining light in ways that resemble advanced optical technology. Could this be a naturally occurring phenomenon, or does it hint at something more deliberate? One controversial study even detected faint, rhythmic pulses in the reflected light, patterns too regular to dismiss as random fluctuations. Whether a fragment of a forgotten world or an anomaly rewriting the rules of mineral formation, the crystal asteroid stands as a testament to the universe's capacity for beauty and mystery. Its flawless facets catch the light of distant stars, whispering secrets of forces we've yet to name, and proving that sometimes reality outshines even our wildest imaginations. Hovering at the edge of the Tadpole Galaxy's gravitational whirlpool, a lone star pulses with a rhythm so sluggish it seems to exist in slow motion. This is the time-dilated star, a celestial anomaly where the very fabric of time bends to an extreme never before observed in nature. While most stars flicker and flare in predictable cycles, this one's light dims and brightens as if trudging through cosmic molasses, with each pulse stretched across years instead of days. The effect is so pronounced that comparing it to neighboring stars feels like watching a hummingbird's wings next to the slow sweep of a sundial's shadow. What could warp time to such a degree? Einstein's theory of relativity offers one possible answer. The star might be entangled in the gravitational grip of an invisible black hole, its orbit dragging it through space-time so warped that seconds there equate to months elsewhere. Near a black hole's event horizon, time dilation becomes extreme. An astronaut falling toward it would appear to freeze in place from an outsider's perspective, their signals growing slower and redder until they vanish. But here's the catch: the time-dilated star isn't near any known black hole. Its surroundings are eerily empty, raising the chilling possibility that whatever's bending time around it doesn't just lurk unseen, it might be woven into the star itself. Some theorists propose an even stranger explanation. What if the star isn't just experiencing time dilation, but is somehow disconnected from the normal flow of space-time? Quantum physics allows for hypothetical defects in the fabric of the universe, cosmic knots where the rules break down. These could act like bubbles of altered physics where time loops, stutters, or flows backward. If such a defect anchored itself to this star, it might explain why all conventional models fail to predict its behavior. Then there's the star's light spectrum, which carries fingerprints of elements that shouldn't exist in its life cycle phase. Certain heavy metals, typically forged in supernova explosions, pepper its outer layers like scars from a timeline that hasn't happened yet. Could this be evidence of time itself unraveling around the star, mixing past and future into a single, tangled moment? Or is the star somehow pulling matter, or even moments from elsewhere in the cosmos? The time-dilated star doesn't just challenge our understanding of relativity. It taunts us with the possibility that time, the one constant we thought we could rely on, might be far more fluid than we ever imagined. Every observation deepens the mystery, leaving scientists to wonder: are we witnessing a cosmic glitch, a doorway to another epoch, or something even more profound, a crack in the clockwork of the universe itself? Hanging like a celestial jellyfish in the Tadpole Galaxy's outer reaches, the bioluminescent cloud pulses with an eerie, living glow. A vast expanse of gas shining not with the harsh light of stellar radiation, but with a soft, rhythmic luminescence that mirrors Earth's deepest ocean trenches. Unlike typical nebulae, which blaze in fiery hues as they're bombarded by nearby stars, this cloud flickers with blues and greens so reminiscent of bioluminescent plankton or deep-sea squid. It's hard not to wonder, could this be the universe's first hint of cosmic life? The chemistry behind the glow is already rewriting textbooks. When astronomers first analyzed the cloud's spectrum, they expected to find the usual suspects: hydrogen, helium, and traces of ionized metals. Instead, they stumbled upon complex organic molecules, some never before seen in space, arranged in structures that absorb and re-emit light with uncanny efficiency. These aren't the chaotic reactions of stellar nurseries. They're precise, almost purposeful, like a celestial version of the chemical reactions that power firefly bellies. One theory suggests the cloud might be filled with exotic, dark chemistry, reactions occurring in the frigid void between stars where temperatures hover just above absolute zero. Under these extreme conditions, molecules could form in ways impossible on Earth, creating light-producing pathways we've yet to discover. But the real controversy lies in the patterns. The bioluminescent cloud doesn't just shine, it pulses in waves that ripple outward like a heartbeat, with fluctuations too regular to dismiss as random turbulence. Some sections brighten in sync, as if responding to an unseen signal, while others dim in perfect opposition, creating a mesmerizing push and pull across light years. Could this be the byproduct of magnetic fields twisting through the gas, or something far more provocative? A handful of astrobiologists have dared to propose that the cloud might harbor a form of macroscopic life, vast, floating organisms metabolizing cosmic rays and stellar winds, their biology so alien we wouldn't even recognize it as life at first glance. Imagine creatures the size of continents, woven from ionized plasma and self-replicating molecules, their life cycles playing out over millennia. Skeptics argue the cloud is more likely a cosmic coincidence, a rare alignment of physics and chemistry that only appears alive. Yet even they can't explain why the light patterns mimic the communication strategies of terrestrial species, where bioluminescence serves as a language in the dark. Whether a natural wonder or something beyond our current understanding, the bioluminescent cloud forces us to confront a humbling truth. The universe is far stranger than we've imagined, and the line between chemistry and life might be thinner than we ever dared to dream. Nestled among the Tadpole Galaxy's swirling stars, 3 enigmatic objects form a shape so precise it feels intentional. A perfect equilateral triangle spanning nearly 1,000 light-years per side. The triangulum anomalies, as astronomers call them, aren't just randomly scattered cosmic features. They're aligned with geometric precision, their positions locked in a configuration that defies the chaos of space. One is a pulsar, its rhythmic flashes unnervingly steady. Another is a vortex of ionized gas spinning like a cosmic whirlpool. The third, a dark, jagged structure, neither asteroid nor comet, that absorbs light so completely it resembles a hole punched through reality. Together, they form a celestial triangle so flawless, the odds of it occurring naturally are astronomically low. So how does such perfection emerge in a universe ruled by randomness? The conventional explanation points to a freakish alignment, a fleeting moment where 3 unrelated objects happen to line up from our vantage point. But here's the problem. The triangulum anomalies have maintained this configuration for centuries, their positions drifting through space in unison, as if connected by invisible threads. Simulations show that without some unseen force actively correcting their paths, gravitational interactions alone should have disrupted the triangle long ago. Some researchers propose an underlying structure, a hidden scaffold of dark matter, perhaps acting like cosmic glue to hold the trio in place. Yet even that theory strains credibility, requiring a density and distribution of dark matter so specific, it's like balancing 3 marbles on a spinning plate in a hurricane. Then there's the far more provocative idea. What if the triangle isn't natural at all? Ancient human civilizations built pyramids and stone circles as landmarks, aligning them with celestial events. Could the triangulum anomalies serve a similar purpose, a beacon or boundary marker left by something or someone? Proponents of this cosmic landmark hypothesis point to the pulsar's behavior. Its radio bursts aren't just regular, they're encoded with mathematical ratios matching prime numbers, a pattern found in no other known pulsar. The gas vortex, meanwhile, rotates at a speed that generates harmonics eerily reminiscent of Earth's musical scales. And the dark structure, its edges are too sharp, its silhouette too geometric, as if machined rather than formed. Skeptics counter that nature is capable of creating its own art. Think of Saturn's hexagon or the fractal branching of lightning. But the anomalies' synchronized movements add another layer of intrigue. Whenever one shifts position, the others adjust within days, maintaining the triangle's perfect proportions. It's as though they're nodes in a vast, invisible network responding to forces we can't yet measure. Whether a cosmic coincidence, a gravitational curiosity, or something far more profound, the triangulum anomalies challenge our assumptions about the universe's architecture. They whisper of order lurking beneath the chaos, a reminder that sometimes the cosmos doesn't just create patterns, it chooses them. Hanging in orbit around a gas giant deep within the Tadpole Galaxy, the metallic moon glides through space like a colossal droplet of quicksilver, its surface so unnaturally smooth and reflective, it warps the starlight into funhouse mirror distortions. Unlike the pockmarked, rocky moons we're accustomed to, this one shows no craters, no mountains, not even the faintest blemish. Instead, its exterior ripples and undulates with the languid grace of a liquid, shifting in slow motion as if responding to cosmic tides we can't perceive. When telescopes first detected it, astronomers assumed they were seeing a trick of the light, perhaps sunlight glancing off an icy surface at just the right angle. But spectral analysis revealed something far stranger. The moon doesn't just reflect light, it amplifies certain wavelengths while suppressing others, as though its surface were engineered to filter starlight like a celestial prism. The closest terrestrial comparison would be Mercury pooled in a petri dish, yet this moon spans nearly 1,000 miles in diameter, making its liquid-like behavior on such a scale utterly unprecedented in nature. What could keep a moon's surface in this bizarre, quasi-liquid state? One theory suggests an exotic form of metallic hydrogen, a substance theorized to exist under extreme pressures inside gas giants might have migrated outward and coated the moon's exterior. On Earth, metallic hydrogen can only be created in labs for fractions of a second under crushing pressures. But here, it could exist as a stable, shimmering ocean, held together by the moon's unusually strong magnetic field. Others propose the surface isn't liquid at all, but a superfluid solid, a quantum material where atoms move in perfect unison, eliminating friction and creating that eerie, flowing appearance. Then there's the more controversial possibility: the metallic moon might not be a moon at all. Its orbit is too precise, its composition too uniform, as if it were placed rather than formed. Some researchers point to its uncanny resemblance to theoretical, smart mirrors, hypothetical megastructures designed to collect and focus sunlight for energy harvesting. Could this be a relic of an ancient civilization's technology, left drifting around a gas giant like a forgotten satellite? The moon's rhythmic pulsations lend credence to this idea. Every 11 hours, its reflectivity spikes in a sharp, artificial-looking pattern, as though cycling through a programmed sequence, but perhaps the most unsettling feature is what lurks beneath. Radar scans reveal dense, geometric structures buried under the metallic surface, clusters of right angles and perfect spheres that defy natural erosion. Are these the remnants of internal machinery, long dormant under layers of liquid metal? Or could they be the architectural bones of something far older, a cosmic artifact waiting to be awakened? The metallic moon refuses to reveal its secrets easily, and until we can send a probe through its shimmering veil, it will remain one of the Tadpole Galaxy's most mesmerizing mysteries. A looking glass hanging in the void, reflecting back not just light, but our own unanswerable questions. Deep within the Tadpole Galaxy's spiral arm, space itself seems to rebel against the laws of physics. The gravity well isn't a pit, it's a reverse pit, a cosmic anomaly where gravity doesn't pull objects inward but violently pushes them away. Picture tossing a rock into a pond, only to watch it launch skyward as if the water spat it back at you. That's the nightmare logic of this region, where the universe's most fundamental force flips its script, turning into a repulsive field so strong it can deflect entire asteroid belts like they're made of tissue paper. At first, astronomers thought they were seeing an illusion, perhaps light bending around a particularly dense cluster of dark matter, but the data told a different story. Probes sent toward the well didn't accelerate as expected, they decelerated as if slamming into an invisible wall. One spacecraft even ricocheted backward, its trajectory bent by what could only be described as negative gravity. The implications are staggering. According to Einstein's equations, gravity is the curvature of spacetime by mass, so what could possibly warp spacetime in reverse? The leading theory points to a hypothetical form of matter called negative mass, a substance that, if it exists, would repel rather than attract everything around it. Most models treat negative mass as a mathematical curiosity, but the gravity well suggests it might be real and concentrated here in terrifying quantities. Imagine a clump of this exotic material lurking at the well's heart, warping the fabric of space like a trampoline stretched upward instead of sagging down. The resulting repulsion would explain why dust clouds near the well ripple outward in perfect concentric rings, as if something unseen is blowing them away like dandelion seeds. But there's a wilder possibility. Some physicists speculate the well might be the mouth of a wormhole, a tunnel through spacetime, except this one isn't just bending space, it's inverting it. Wormholes are typically imagined as shortcuts between distant points, but if their entrances behave like the gravity well, they could theoretically spit objects out into other universes or even other times. The well's repulsive force might then be a side effect of spacetime folding in on itself, creating a region where the rules of attraction no longer apply. What lends credence to this idea are the well's strange emissions. Sensors detect faint bursts of high-frequency gravitational waves, ripples in spacetime emanating from its center in perfect, repeating intervals. These pulses don't match any known astrophysical phenomena, but they do resemble theoretical predictions for a stable wormhole's echo. Even more bizarre, the well's repulsion isn't constant. It fluctuates in strength, sometimes surging violently enough to shred nearby gas clouds, other times fading to near stillness. This inconsistency suggests something dynamic is happening at its core, perhaps a tunnel flickering in and out of existence or struggling to maintain its shape under the strain of exotic physics. Whether a pocket of negative mass or a doorway to the unimaginable, the gravity well stands as a stark reminder that the universe still holds forces beyond our textbooks. It's a place where down becomes up, where the cosmos rewrites its own rules, and where every new observation leaves us with more questions than answers. One thing's certain, if we ever unlock its secrets, we won't just be studying a strange object in space. We'll be rewriting the very definition of reality. Stretching across the void like a crack in the fabric of reality, the frozen lightning is a filament of pure plasma, one that should have vanished in a flash, yet hangs suspended in space as if time itself stopped mid-strike. This jagged bolt, spanning nearly 100 light-years, crackles with energy even now, its fiery tendrils frozen in a split-second pose of violent release. But this isn't some artistic rendering or long exposure photograph. It's real, it's persistent, and it defies every law governing how plasma behaves in the vacuum of space. Under normal circumstances, plasma, the fourth state of matter where atoms are ripped apart into charged particles, should dissipate almost instantly without containment. Yet the frozen lightning has remained intact for centuries, its structure eerily identical to the fractal branching of terrestrial lightning, but scaled up to cosmic proportions. The leading theory suggests an unfathomably strong magnetic field might be acting as an invisible cage, twisting around the plasma like a snake constricting its prey. Fields this intense could theoretically trap the charged particles mid-eruption, forcing them into a stable, looping current. But here's the catch. No known celestial object nearby has the magnetic power to sustain such a prison. That absence has led to a spine-tingling alternative explanation. What if the frozen lightning isn't trapped at all but preserved? Imagine a catastrophic event, perhaps a hypernova or a collision between neutron stars, so violent that it briefly warped spacetime itself. In that instant, as energy erupted across dimensions, the lightning might have been stamped onto the cosmos like a fossil in stone, its image embedded into the fabric of reality. It's a phenomenon akin to ball lightning on Earth, those rare, glowing orbs that seem to defy physics, except scaled up to galactic proportions. Even stranger are the whispers of structure within the bolt. High-resolution scans reveal finer filaments weaving through the main arc, patterns too intricate to arise from chaos alone. Some researchers compare it to Lichtenberg figures, the branching scars left by lightning on skin, or wood, suggesting the frozen lightning might bear the fingerprint of whatever force created it. Others note eerie resemblances to neural pathways or river deltas, as if nature's brushstrokes repeat across scales from the microscopic to the cosmic. Then there's the silence. Despite its appearance, the frozen lightning emits no radio waves, no X-rays, none of the screaming static typical of high-energy plasma. It's as though the bolt is muted, its energy locked away in some unobservable state. This has spurred wilder theories, like the lightning being a topological defect in space-time, not left over from the early universe, where the laws of physics briefly tangled into something unrecognizable. Whether a magnetic marvel, a cosmic fossil, or something beyond our current science, the frozen lightning stands as a stark reminder. The universe is capable of pressing pause on its own chaos. And in that pause, we catch glimpses of forces so profound, they hover just beyond the edge of understanding, a snapshot of violence frozen in eternity, waiting for us to decipher its meaning. Buried in the Tadpole Galaxy's turbulent heart, a quasar screams into the void, but its cry doesn't fade. Instead, it echoes, bouncing back with eerie precision like a voice trapped in a cosmic canyon. This is the echoing quasar, a hyperactive black hole whose radio bursts don't just dissipate into silence, they return, replaying the same sequence of tones and pulses years later with near-perfect fidelity. It's as if the universe pressed record on this quasar's outburst, then decided to hit replay in a loop that defies all known astrophysics. Quasars are normally chaotic beasts, their jets of energy flaring unpredictably as they devour surrounding matter. But this one behaves differently. When astronomers first detected its initial radio blast, a jagged spike of energy spanning multiple frequencies, they expected it to vanish into the noise of space. Instead, precisely 4 years and 7 months later, the same signal returned, slightly fainter but structurally identical, as though reflected off some invisible surface. Then it happened again and again. The intervals weren't random. Each echo arrived exactly 1,700 days after the last, a clockwork repetition that sent theorists scrambling for explanations. The leading natural hypothesis suggests an unimaginably vast echo chamber of ionized gas might surround the quasar. Picture shouting into a tunnel and hearing your voice rebound off distant walls. In this case, the walls could be clouds of plasma light years thick, curved just right to catch the quasar's emissions and funnel them back toward us. Simulations show that under extreme conditions, certain donut-shaped plasma structures could theoretically create this effect, but they'd need to be perfectly aligned and stable for centuries, a statistical fluke so unlikely it borders on cosmic satire. Yet there's a more unsettling possibility lurking in the data. The echoes aren't mere copies, they're filtered. Certain frequencies return sharper than others, as if whatever's reflecting the signal is selectively amplifying specific parts, almost like an equalizer tuning the universe's soundtrack. Even stranger, buried in the echoes are subtle mathematical patterns, ratios matching prime numbers, and Fibonacci sequences reminiscent of the coded pulses from the triangulum Anomalies. Could this be natural resonance or something more intentional? A minority of researchers argue the quasar might be purposefully embedded in a megastructure, a kind of galactic-scale recorder designed to capture and replay its outbursts as a beacon or message. Imagine a civilization so advanced it harnesses black holes as communication towers, their lethal energies sculpted into signals that echo across millennia. Then there's the silence between echoes. Most quasars emit a constant hiss of radio noise, but this one falls utterly quiet between repetitions, as if someone or something is hitting pause. That absence of background static deepens the mystery. Natural cosmic echoes usually blur into a haze of overlapping reflections, but the echoing quasar's returns are crisp, clean, and isolated, like a vinyl record's needle lifted between tracks. Whether a freak of plasma physics or a whisper from something beyond our understanding, one thing's certain: this isn't just a quasar. It's a cosmic boomerang hurling its secrets into the dark, then waiting for us to catch them as they return. Among the swirling mysteries of the Tadpole Galaxy, few sights are as hypnotic as the binary vortices, twin maelstroms of warped spacetime locked in a dance so intricate they seem to bend the very fabric of reality around them. Picture two colossal whirlpools spinning in perfect opposition, each stretching over 300 light-years wide, their gravitational tides weaving together like cosmic braids. These aren't just pockets of distorted space, they're engines of pure distortion, twisting the paths of nearby stars into spirals as if the galaxy itself were pouring down an invisible drain. What sets these vortices apart is their synchronicity. Unlike typical gravitational anomalies which drift independently, these two move as if tethered by unseen strings, their rotations perfectly mirrored. When one speeds up, the other slows in response, maintaining a balance so precise it resembles the interplay of gears in some celestial clockwork. The energy radiating from their edges defies explanation, a shimmering aurora of particles accelerated to near light speed, creating ribbons of light that pulse in rhythms eerily reminiscent of a heartbeat. Astrophysicists are torn between two extraordinary possibilities. The first paints the vortices as natural, albeit extreme, manifestations of frame dragging, an effect predicted by Einstein where massive rotating objects literally drag spacetime around with them. If two supermassive black holes orbited each other at relativistic speeds, their combined spin could twist the surrounding void into these helical nightmares. Yet scans reveal no black holes at their cores, just empty, howling voids where the laws of physics seem to fray at the edges. That absence fuels the second, more radical theory. The binary vortices might be artificial, or at least manipulated. Their symmetry is too perfect, their energy output too finely tuned. Some models suggest they could act as natural particle accelerators, their opposing spins funneling cosmic rays into collisions of unimaginable energy. Others speculate they're unintended byproducts of something far grander, perhaps relics of an ancient experiment to harness spacetime itself, or even failed wormholes frozen mid-formation. The most tantalizing clue: the vortices emit gravitational waves at frequencies that match theoretical predictions for stabilized wormhole throats, leading some to wonder if these aren't just distortions but doorways, their spinning walls acting as gates to distant reaches of the cosmos. Then there's the mystery of the echoes. Every 53 years, the vortices release matching bursts of low-frequency radiation, pulses that ripple across the galaxy like the tolling of some deep space bell. These emissions don't decay as expected. Instead, they linger, vibrating the interstellar medium like a tuning fork struck against the void. Could this be evidence of resonant chambers hidden within the vortices, structures designed to amplify and direct energy? Or are we witnessing the death cries of stars torn apart not by gravity, but by forces we've yet to name? Whether natural wonders or cosmic tools, the binary vortices challenge our understanding of spacetime's flexibility. They whisper of a universe where space isn't just empty, it's alive, malleable, and perhaps even sculptable by hands we can't yet see. And as they continue their endless waltz, they remind us that some of nature's most profound secrets don't hide in darkness. They spin in plain sight, daring us to unravel their purpose. In the heart of the Tadpole Galaxy, something vast stirs unseen, an immense presence detectable only by the way it warps the fabric of space around it. The invisible giant doesn't glow, doesn't reflect, doesn't emit a single whisper of radiation. It exists solely as a gravitational shadow, a void where stars and gas clouds move as if tugged by an unseen hand. When telescopes scan this region, they capture nothing but empty space, yet the trajectories of nearby objects tell a different story. Planets, asteroids, even light itself bends around this cosmic phantom as if avoiding an obstacle no one can see. What could lurk in this invisible expanse? One spine-chilling possibility is that we're witnessing a form of dark matter so dense, so alien, it doesn't just evade light, it swallows it whole. Most dark matter interacts with the universe only through gravity, but this anomaly takes that elusiveness to terrifying extremes. Computer simulations struggle to replicate its behavior without invoking new physics like sterile dark matter, a hypothetical variant that shuns even the weak nuclear force, rendering it utterly undetectable except by the way it warps spacetime. If such matter exists here in concentrated form, it could rewrite our understanding of the universe's hidden scaffolding. But there's a second, even more provocative theory, that the invisible giant isn't natural at all. Imagine a starship the size of a solar system, its surface engineered to bend light and energy around it, rendering it perfectly cloaked. Advanced civilizations might harness such technology to traverse the cosmos unseen, leaving only gravitational ripples in their wake. The giant's precise spherical distortion field resembles theoretical models of stealth drives, propulsion systems that manipulate spacetime to avoid detection. Even more telling, the shadow moves not with the galaxy's natural flow, but at a slight angle as if navigating with purpose. Then there's the silence. Most massive objects, black holes, neutron stars betray their presence through X-rays or radio waves as they tear matter apart. The invisible giant emits nothing, not even the faintest thermal signature. It's as though whatever lurks within has mastered the art of cosmic camouflage, hiding not just from our eyes, but from the very laws of physics as we know them. Whether a new frontier of dark matter or something far more deliberate, this gravitational ghost challenges our deepest assumptions about what can or should exist in the darkness between the stars. Hovering in the dust-strewn tail of the Tadpole Galaxy, the Clockwork Nebula spins with uncanny precision, its luminous gas clouds arranged in concentric rings that rotate in perfect interlocking synchrony, like the gears of some colossal celestial timepiece. At first glance, it resembles an antique watch frozen mid-tick, its intricate arcs and spirals locked into ratios so precise. Astronomers initially dismissed it as a glitch in their imaging software. But the nebula's rhythm is real. Every 73 years, like clockwork, its outermost ring completes a full rotation, triggering a cascade of movement inward as each subsequent ring turns in exact mathematical harmony. A cosmic demonstration of orbital mechanics playing out on a scale that dwarfs solar systems. The nebula's origin split scientists into two camps. The naturalists argue it's a freakish byproduct of overlapping gravitational tides, perhaps the remnants of two neutron stars locked in a decaying orbit, their immense magnetic fields sculpting the surrounding plasma into these eerie geometric patterns. Under this model, the nebula's regularity arises from resonance, the same phenomenon that keeps Jupiter's moons synchronized or causes playground swings to pump in unison when pushed at just the right intervals. If the gas cloud's rotation aligns with the underlying gravitational pulses, the system could self-regulate, its motion growing more precise over millennia as chaotic elements are gradually ejected. But the other camp points to unnerving details that defy natural explanations. The nebula's gears don't just turn, they correct. Whenever external forces like passing stars or gas streams nudge the rings off rhythm, the system recalibrates within decades, adjusting angular momentum between layers as if guided by an invisible hand. Even more perplexing are the jagged spikes of ionized matter along the ring's edges that mesh together like actual cogs, transferring energy between sections with near-perfect efficiency. Natural processes rarely produce such clean, load-bearing structures. Even spiral galaxies, the closest natural comparison, show frayed, asymmetric arms. Then there's the light. The nebula emits not just the soft glow of heated gas, but pulsed beams of coherent radiation, focused, laser-like streams that flare whenever the gears align at specific angles. These beams don't scatter into space, they funnel toward a central void, an empty region where telescopes detect no central object. Some theorists suggest the entire nebula might be a colossal machine, its gears acting as lenses or amplifiers for energy being harvested or transmitted from that hollow core. Could this be the remnant of a Dyson swarm, a megastructure built to harness a star's power, now dormant and gathering dust? Or is it something far older, a relic from a prior universe where physics permitted such cosmic clockwork to form naturally? The Clockwork Nebula doesn't just challenge our understanding of astrophysics, it blurs the line between nature and artifice. Whether a masterpiece of celestial mechanics or a fossilized machine beyond our comprehension, its ticking gears count down to a truth we've yet to uncover, that the universe may harbor designs far stranger than anything we've dared to engineer. Hidden within the Tadpole Galaxy's turbulent dust clouds, the quantum fern unfurls its luminous tendrils, a fractal energy field so intricate, it appears to grow like a living organism, branching and dividing in patterns that mirror ferns swaying in an unseen cosmic breeze. But this isn't just a beautiful accident of physics. Every filament of its structure pulses with synchronized light, as if the entire formation shares a single nervous system, reacting to stimuli we can't perceive. What makes this phenomenon truly extraordinary isn't just its shape. It's the way it behaves, shifting and adapting in real time, as though making decisions. At the heart of the mystery lies a bizarre quantum signature. Scans reveal particles within the fern's filaments are entangled across vast distances, their states linked instantaneously no matter how far apart they drift. In earthly labs, quantum entanglement is fragile, lasting mere seconds before decoherence tears it apart. Here, entanglement persists for years, even as the fern's structure expands across light years, defying everything we know about quantum stability. Some researchers suggest the fern might be tapping into a hidden layer of reality, where quantum coherence is the default, not the exception. A place where the universe's underlying code is exposed, allowing information to propagate without resistance. Then there's the fern's motion. Unlike inert cosmic structures, it doesn't just drift passively. Its branches recoil from passing gamma rays, curl toward magnetic anomalies, and occasionally, most unsettling of all, reach out to nearby energy sources as if feeding. One startling observation caught its tendrils wrapping around a dying star, siphoning charged particles in a manner eerily reminiscent of terrestrial vines climbing toward sunlight. Astrophysicists are divided. Could this be a natural plasma structure shaped by electromagnetic forces we've yet to model? Or does the fern exhibit something far more unsettling? A primitive form of cosmic sentience, its fractal network acting like a decentralized brain. The most tantalizing clue comes from its communication. The fern emits bursts of low-frequency radio waves, but these aren't random. They follow nested patterns, repeating sequences that resemble mathematical constants or the error-correcting codes used in human digital transmissions. When one branch is stimulated, the response ripples through the entire structure faster than light should allow, suggesting information travels via quantum tunneling, a process where particles bypass spacetime altogether. If true, the fern might be a natural quantum computer, processing information on scales that dwarf human technology, perhaps even simulating environments within its glowing web. Whether a fluke of quantum physics or a glimpse of an entirely new form of existence, the quantum fern forces us to confront a radical idea. The line between life and non-life might blur in the depths of space. It challenges us to expand our definition of intelligence, to consider that sentience could arise not just in carbon-based bodies, but in shimmering fields of entangled energy, thinking thoughts as vast and slow as the cosmos itself. And as it continues to pulse and shift in the darkness, it whispers a question we're only beginning to grasp. What does it mean to be alive when the universe itself might be watching? Drifting silently through the outer reaches of the Tadpole Galaxy, the hollow planet hangs in the void like a cosmic eggshell, its surface pockmarked with vast, gaping chasms that lead not into rocky depths, but into an impossible emptiness. Scans reveal the shocking truth. This world is a literal shell, its crust barely 50 miles thick in places, enveloping a cavernous interior large enough to swallow entire moons whole. For context, Earth's crust averages about 19 miles beneath oceans and up to 40 miles under continents. This planet's entire outer layer is as fragile as an autumn leaf compared to the crushing pressures that typically mold planetary interiors. How could such a delicate structure survive the violence of space? The planet's composition only deepens the riddle. Its crust isn't just thin, it's reinforced, laced with metallic alloys arranged in lattice-like patterns that mirror the load-bearing frameworks of human-made bridges. These aren't the random veins of ore found in ordinary planets. They're geometric, almost engineered, as if designed to prevent collapse. Some researchers propose natural explanations, like a rogue white dwarf star stripping away the planet's mantle in an ancient grazing collision, leaving behind a hollowed husk. Others point to a freak bubble in the primordial nebula where the planet formed a void preserved like a fossil in molten rock as the world cooled. But the most tantalizing theory whispers of artifice. Scattered across the planet's yawning sinkholes are smooth, vertical shafts that plunge straight into the darkness, tunnels too straight, too evenly spaced to be the work of geology alone. Their walls' bare tool marks eerily reminiscent of industrial drilling, though on a scale dwarfing any human endeavor. Could this be the aftermath of a mining operation so vast it consumed a planet's core? Ancient alien megastructures are a trope of science fiction, yet here we might be staring at evidence of exactly that. A world hollowed out over millennia, its resources extracted by hands or machines we can scarcely imagine. Then there's the eerie silence from within. Most planets hum with seismic activity, their interiors churning with molten rock and shifting tectonic plates. The hollow planet is clinically dead. No quakes, no magnetic field, not even the faintest thermal signature to betray residual heat. It's as though whatever once filled this shell didn't just leave, it was erased down to the last atom. Some models suggest the interior might house a stabilized exotic matter core, a theoretical substance that counteracts gravity, preventing the crust from crumbling under its own weight. Others wonder if the entire planet is a dormant container waiting for something to refill it. What lingers most unsettlingly is the planet's orbit, a slow, precise spiral that defies natural decay. Empty shells this massive should destabilize over eons, yet the hollow planet drifts along its path with unnatural precision, as if anchored by something unseen. Could its creators still be out there, maintaining their abandoned work from the shadows? Or is the planet itself a relic of physics we've yet to uncover, a cosmic riddle carved in stone and silence? Either way, it stands as a monument to the universe's capacity for wonder, challenging us to reconsider not just how planets form, but who or what might reshape them. Cutting through the darkness of the Tadpole Galaxy with metronomic precision, the lighthouse pulsar stands as nature's most unerring timekeeper, a stellar corpse spinning so rapidly, its beams sweep the cosmos like clockwork, flashing brighter than entire solar systems with each rotation. Unlike ordinary pulsars whose radio waves scatter unpredictably, this one fires twin jets of radiation in perfectly opposed directions, slicing through space like a lighthouse's blade of light across a stormy sea. What makes these beams extraordinary isn't just their power, it's their unnatural consistency. Over decades of observation, their pulse timing hasn't drifted by even a millisecond, a stability that rivals atomic clocks crafted by human hands. The physics behind this precision is staggering. Born from the collapse of a massive star, the pulsar's core, a neutron star denser than a mountain compressed into a sugar cube, spins 700 times per second, its magnetic field trillions of times stronger than Earth. These forces accelerate particles to near light speed, funneling them into beams so focused they could illuminate a planet light years away like a spotlight. Yet the real marvel lies in the beam's alignment. Most pulsars wobble as they spin, their radiation sweeping erratically like a flickering bulb. The lighthouse, by contrast, rotates with freakish balance, its axis locked toward distant galactic landmarks as if oriented. This eerie stability has led some scientists to propose a radical idea. Could the lighthouse be more than a celestial accident? Its beams intersect with staggering accuracy at key points, a rogue planet here, a dense nebula there, almost like waypoints on a cosmic highway. Ancient human civilizations built lighthouses to guide sailors. Might an advanced culture have engineered this pulsar as a navigational marker for interstellar travelers? The notion isn't pure fantasy. Mathematicians have noted that the timing of its pulses encodes prime numbers, a universal language often proposed for extraterrestrial communication. Even skeptics admit the odds of such alignment occurring naturally are astronomically low. But the pulsar's deepest mystery lurks in its silence. Between its laser-like beams, the lighthouse emits no residual radiation, an absence as conspicuous as a spotlight vanishing between sweeps. This suggests something might be filtering its emissions, amplifying select frequencies while suppressing others. Could there be structures near the pulsar, lenses, reflectors, or even machinery, sculpting its light into a deliberate signal? The beam's spectral signatures hint at artificial manipulation, with telltale absorption lines resembling those predicted for hypothetical quantum filters. Whether a masterpiece of natural physics or an artifact of cosmic engineering, the lighthouse pulsar challenges our assumptions about randomness in the universe. Its rhythmic flashes pierce the darkness not just as a curiosity, but as a question. Are we witnessing nature's perfection or the fingerprints of something or someone who mastered the stars long before we existed? And as its light continues to sweep the void with mechanical certainty, it serves as a reminder that some beacons don't just guide, they wait. Floating in the Tadpole Galaxy's outer reaches, the cosmic jellyfish drifts through the void with an eerie, lifelike grace, its luminous tendrils pulsing rhythmically as though breathing in the darkness. This sprawling nebula stretches over 200 light-years, its glowing filaments swaying in hypnotic waves that mirror the undulations of Earth's oceanic jellyfish. But here's what defies explanation. Those rhythmic pulses aren't random. They follow a precise, repeating sequence, brightening and dimming in cycles that last exactly 47 hours, as if timed by some unseen cosmic metronome. At first glance, the phenomenon seems like a quirk of plasma physics. Nebulae often shimmer under the influence of nearby stars, their gases energized into flickering displays. Yet the jellyfish's pulses persist even in regions starved of stellar radiation, its tendrils lighting up from within like bioluminescent threads in a deep-sea current. Spectroscopic analysis reveals no conventional energy source, no hidden stars, no collapsing cores, just a bizarre, self-sustaining loop of ionization and recombination. Some astrophysicists argue this could be evidence of a previously unknown plasma state, where charged particles organize into standing waves, creating stable, pulsating structures. Imagine striking a bell, but instead of the sound fading, the vibrations sustain themselves indefinitely, resonating through the nebula's delicate framework. But there's another, far more provocative camp of researchers who see something else entirely. The jellyfish's tendrils don't just pulse, they react. When probes have fired microwaves or radio bursts into the nebula, specific filaments have twitched in response, curling away from the stimuli like living nerve endings. Even stranger, the nebula's heartbeat occasionally skips or adjusts, as if recalibrating to some internal rhythm or external signal we can't detect. These anomalies have led a minority of scientists to float a radical hypothesis. What if the cosmic jellyfish isn't just a cloud of gas but a dormant entity, a form of life so alien we don't even recognize it as alive? The idea isn't as far-fetched as it sounds. On Earth, certain slime molds exhibit primitive problem-solving behaviors despite having no nervous system. Could the jellyfish be a macroscopic cousin, a life form built from magnetized plasma instead of carbon, its thoughts unfolding over centuries as it drifts between the stars? Proponents point to the nebula's intricate branching patterns, which mirror the growth of fungal networks or neural pathways, suggesting a complexity beyond mere fluid dynamics. Skeptics counter that nature often repeats patterns across scales. Lightning bolts and river deltas share similar fractal designs, yet no one calls them sentient. Debate rages, but one clue keeps the mystery alive. Deep in the nebula's core, sensors have detected faint, coordinated radio bursts, clusters of signals that resemble error-correcting codes in human data transmissions. Are these just echoes of turbulent magnetic fields, or could they be something else? Until we send a probe deep into those glowing tendrils, the cosmic jellyfish will remain both a scientific enigma and a poetic riddle, pulsing in the dark like a question mark written in starlight. The bizarre objects scattered across the Tadpole Galaxy have ignited fierce debates among scientists, with theories ranging from cosmic flukes to hints of civilizations beyond our wildest imagination. Take the Twisted Nebula's eerie spiral. Some astrophysicists argue it's the result of a hyper-rare magnetic vortex, where galactic winds coil around a dormant black hole like thread around a spindle. Others counter that no known magnetic field could maintain such geometric precision across light years, suggesting instead the influence of quantum filaments, theoretical cosmic strings left over from the Big Bang, warping space-time like invisible wires tugging the nebula into shape. Then there's the mirror planet, its flawless metallic sheen sparking whispers of artificial origins. Mainstream planetary scientists propose it could be a fragment of a shattered white dwarf, its crust compressed into a crystalline metal shell by gravitational forces we've yet to model. But a vocal minority points to its unnatural light-filtering properties as potential evidence of engineering, comparing its surface to adaptive optics used in advanced telescopes. The controversy grows hotter when you consider its orbit, a path so irregular it resembles a vessel adrift rather than a planet born from stellar accretion. The phantom star clusters disappearing act fuels even wilder speculation. While most astronomers blame gravitational lensing from dark matter clumps, a fringe group argues the cluster might be phasing in and out of our dimension, caught in a bubble of unstable space-time. This theory, though controversial, gains traction from the cluster's eerie synchronization with gamma-ray bursts in a neighboring galaxy, as if some unseen connection tugs at the fabric of reality itself. Skeptics dismiss this as coincidence, but the mathematical models are hauntingly precise, aligning with equations from string theory that predict transient dimensional overlaps. Perhaps no object divides researchers more than the glowing hexagon. Traditionalists insist it's a standing wave in the galaxy's magnetic field, frozen in a perfect geometric resonance. Yet critics note that such waves should degrade over millennia, while the hexagon's edges remain razor-sharp after eons. A daring alternative theory suggests it's a cosmic circuit, a natural superconductor channeling energy from the galaxy's core, an idea bolstered by the rhythmic pulses that match models of superconducting loops. Then there's the elephant in the room. The hexagon's pulse intervals correspond to prime numbers, a pattern so statistically unlikely in nature that even hardened skeptics admit it raises uncomfortable questions. The debate turns existential with the void cube. Some cosmologists propose it's a pocket of negative space-time, a region where the universe's expansion accelerated so violently during inflation that it tore a hole in the cosmic tapestry. Others whisper about universe errors, glitches in the fundamental code of reality, like corrupted pixels in a simulation, the most unsettling hypothesis. The cube might be a deliberate erasure, a region scrubbed clean by an intelligence wielding physics we can't yet fathom. After all, nature abhors a vacuum, but this vacuum abhors nature. Even the dancing galaxies, with their synchronized orbits, split scientific opinion. Dark matter purists argue their movements require a halo of invisible mass so dense it would rewrite our understanding of galaxy formation. Yet a growing faction points to anomalies in their radio emissions patterns resembling theoretical blueprints for gravity engines, hypothetical megastructures that could steer stars like ships on a cosmic sea. The galaxy's paths, they note, trace the same spirals seen in particle accelerator experiments when manipulating miniature gravitational fields. Is this proof of alien engineering? Not necessarily, but it forces us to confront an unnerving possibility that some mysteries in the Tadpole Galaxy might not just defy our current science, they could be operating on science we haven't discovered yet. What unites these theories isn't just their audacity, but their humility. Each one, no matter how outlandish, underscores how little we truly know about the universe's rulebook. The Tadpole Galaxy's oddities aren't just cosmic curiosities. They're litmus tests for the boundaries of human imagination, proving that reality, when pressed, can outshine even our wildest fantasies. And as long as these objects linger in the void, whispering their riddles, they'll keep scientists and dreamers awake under the stars, chasing answers at the edge of understanding. The mysteries of the Tadpole Galaxy won't remain out of reach forever. Cutting-edge technology is poised to peel back the veil on these cosmic oddities, and leading the charge is the James Webb Space Telescope, our most powerful window into the universe's deepest secrets. With infrared vision capable of piercing dust clouds that once hid objects like the Twisted Nebula and bioluminescent cloud, Webb is already rewriting the rules of astrophysics. Its sensors can detect the faint heat signatures of rogue planets, map the molecular composition of distant nebulas, and even analyze the light filtering through the mirror planet's unnatural surface. Every new observation brings us closer to understanding whether these anomalies are natural wonders or something far more extraordinary. But Webb is just the beginning. The upcoming Nancy Grace Roman Space Telescope, set to launch in the next few years, will survey vast swaths of the sky with a field of view 100 times wider than Hubble's. This makes it the perfect tool to track elusive phenomena like the phantom star cluster's random disappearances or monitor the dancing galaxy's synchronized orbits over decades. Roman's ability to measure the precise positions and motions of billions of stars could reveal hidden gravitational forces, perhaps even the dark matter structures that might be puppeteering these cosmic oddities. On the ground, the Extremely Large Telescope, or ELT, will soon peer into the Tadpole Galaxy with unprecedented clarity. Its 39-meter mirror, nearly 4 times wider than any current telescope, will resolve details as small as a soccer field on the Moon's surface from Earth. Imagine training that power on the hexagon's razor-sharp edges or the lashing singularity's chaotic jets. The ELT could finally capture the magnetic fields warping the Twisted Nebula or detect the hypothetical quantum defects distorting time around the time-dilated star. Then there's the wild-card Breakthrough Starshot. This ambitious initiative aims to send gram-scale probes to nearby star systems at 20% the speed of light using laser propulsion. While the Tadpole Galaxy's 420 million light-year distance puts it far out of reach for now, the technology being developed could pave the way for future interstellar missions. Picture fleets of microprobes equipped with quantum sensors, capable of transmitting data from inside the void cube's oppressive darkness or skimming the surface of the hollow planet to probe its artificial-looking tunnels. Perhaps the most tantalizing tool on the horizon isn't a telescope at all, but a detector. The Laser Interferometer Space Antenna, or LISA, will float in orbit as the first dedicated gravitational wave observatory in space. Sensitive enough to hear the ripples from merging supermassive black holes billions of light-years away, LISA could eavesdrop on the binary vortice's hypnotic dance or decode the invisible giant's gravitational whispers. If dark matter or higher dimensions are at play in the Tadpole Galaxy, LISA recordings might hold the key. Each of these missions carries the promise of revelation, but also the certainty of new questions. For every mystery solved about the Tadpole Galaxy's 30 strange objects, another will likely emerge, pushing the boundaries of our curiosity further into the unknown. The universe has a habit of resisting simple explanations, and these enigmatic structures are no exception. Whether through the lens of a telescope, the data stream of a probe, or the ripple of space-time itself, one thing is clear: the golden age of cosmic discovery is just beginning, and the Tadpole Galaxy's secrets won't stay hidden for long. The strange objects of the Tadpole Galaxy have seeped far beyond the realm of astrophysics, sparking imaginations and reshaping culture in ways only the most profound cosmic mysteries can. Science fiction authors have long mined these anomalies for inspiration, weaving them into stories that blur the line between cosmic wonder and existential horror. Take the Glowing Hexagon. Its unnerving geometric perfection mirrors the alien monolith from 2001, a space odyssey, while the void cube's absolute nothingness evokes the terrifying void beyond the event horizon. These aren't just plot devices, they're modern mythologies tapping into humanity's oldest fear, the terror of the incomprehensible. Artists, too, have turned the Tadpole's oddities into visual symphonies. Digital creators render the binary vortices as swirling, hypnotic mandalas, their fractal patterns echoing sacred geometry across cultures. The mirror planet's flawless surface has become a canvas for surrealist painters who use its otherworldly reflectivity to explore themes of identity and perception. Even fashion designers have taken cues, with one avant-garde Parisian collection featuring garments that mimic the bioluminescent cloud's eerie pulses, their fabrics embedded with fiber optics that flicker in primal, organic rhythms. These creations don't just depict space, they translate it, turning raw cosmic data into something visceral and human. Philosophers and futurists see something deeper in these anomalies, a challenge to our very understanding of reality. The time-dilated star's warped chronology fuels debates about the nature of time. Is it a river, a web, or something far stranger? The quantum fern's entangled particles have become a favorite metaphor for interconnectedness, cited in everything from ecology treatises to spiritual manifestos. And then there's the hollow planet, its vacant core a Rorschach test for our anxieties about consumption and emptiness in an age of planetary crisis. These objects aren't just studied, they're interpreted, becoming mirrors for our collective hopes and dreads. Even gaming and virtual reality have embraced the Tadpole's mysteries. The indie horror game Velvet Void casts players as an astronaut exploring a derelict ship near the cube's edge, where the laws of physics unravel in real time. Meanwhile, VR platforms use the dancing galaxy's synchronized orbits as the backdrop for meditative experiences, their slow cosmic ballet programmed to sync with brainwave-altering soundscapes. These interactive interpretations don't just entertain, they let audiences inhabit the awe these objects inspire, forging emotional connections that telescope images alone can't achieve. What makes the Tadpole Galaxy's influence so enduring isn't just its strangeness, but its ambiguity. These objects live in the liminal space between known and unknown, daring us to project meaning onto them. They're Rorschach blots written in starlight, reflecting back whatever questions we bring, whether about alien life, the universe's origins, or our own fragile place within it. And as long as they drift out there, pulsing with secrets, they'll keep igniting that most human of sparks, the urge to stare into the dark and dream. Now it's your turn. We've journeyed through cosmic whirlpools, time-bending stars, and geometric riddles. But which of these 30 strange objects captured your imagination the most? Was it the hollow planet with its impossible caverns and whispers of ancient mining, or the mirror planet reflecting starlight with almost too much precision? Maybe the Twin Pulsars, spinning in perfect harmony like a celestial metronome, left you wondering if the universe has its own rhythm. Drop your vote in the comments below. We're dying to know which anomaly sparks your curiosity. And here's where it gets even more exciting. Some of these objects defy not just science but logic itself. The void cube, for example, could it really be a tear in space-time, or is there a darker explanation we haven't even considered? The bioluminescent cloud pulses like something alive, but what if it is? Let your theories run wild. Maybe you think the clockwork nebula's gears hint at a super-advanced civilization, or perhaps the time-dilated star is proof that black holes can manipulate time like a cosmic remote control. This isn't just about picking a favorite, it's about stepping into the shoes of the astronomers staring at their screens, baffled and thrilled by these discoveries. So go deeper, tell us why your pick stands out. Is it the sheer beauty of the quantum fern's fractal glow, or the chilling mystery of the invisible giant, a gravitational ghost lurking unseen? Your ideas might just spark the next big hypothesis. After all, some of history's greatest breakthroughs started with someone asking, "What if?" Don't hold back. The Tadpole Galaxy's enigmas are a playground for the imagination, and your perspective could be the missing piece we've all overlooked. Whether you're team cosmic jellyfish or team lashing singularity, one thing's certain: the universe is stranger than fiction, and the best stories are still being written by science, by wonder, and maybe, just maybe, by you. From the Twisted Nebula's impossible spirals to the hollow planet's cavernous silence, these 30 cosmic oddities prove one thing: our universe is far stranger than we ever imagined. Each object we've explored isn't just a curiosity, it's a crack in the foundation of our understanding, a whisper that there's so much more lurking beyond the edge of our textbooks. Think about it. The phantom star cluster vanishes without a trace, the quantum fern pulses with what might be cosmic sentience, and the void cube stares back at us with perfect geometric nothingness. These aren't just mysteries, they're invitations. What's truly humbling isn't just how little we know, but how much we're allowed to discover. The Tadpole Galaxy, with its freakish collection of anomalies, feels less like a random patch of space and more like a grand cosmic experiment, one where the universe is testing the limits of its own rules. Maybe that's the most exciting takeaway. Every bizarre object we've encountered isn't a dead end. It's a signpost pointing toward undiscovered physics, hidden dimensions, or even, dare we say it, echoes of intelligence beyond our own. And here's the kicker: we've barely scratched the surface. For every object we've named, there are thousands more waiting in the dark, each with the potential to rewrite the story we tell about reality. That's why curiosity isn't just a trait, it's our compass. Whether you're team natural wonder or team cosmic conspiracy, one thing's certain: the universe isn't done surprising us. So keep looking up, keep questioning, and most importantly, stay hungry for the next great mystery. The cosmos is counting on us to pay attention, because the wildest chapters of this story haven't even been written yet. If these cosmic riddles left you as awestruck as they left us, don't let the journey end here. Hit subscribe, because the universe has plenty more tricks up its sleeve, and we're just getting started. Until next time, keep wondering, keep exploring, and remember, the weirdest stuff out there, it's not science fiction. It's just science we haven't figured out yet.